Hello, I'm Verdi Augusto. This is the Schumann Resonance Harmonics channel on YouTube and on Facebook. Thank you for being here. I appreciate all the comments, love, the share. If you're new here, welcome. Please like, share, comment, and subscribe. If you're not getting this immediately, don't be discouraged because it takes some time. It didn't take me instantly to get this, and so it develops over the course of time. All right, so I'm just going to get right into this. I'm in the movie making vibe. I already just did part B of this, and so I'm just going to get right into or I'm sorry, I just did part A. I'm just going to get into part B right here. And so essentially we're looking at the correspondence or the correlation between amplitude spikes on the VLF range, which is here from Cumiana, and you see these as well, VLF or emissions in the VLF range, and the correspondence with earthquakes. All right, so that's where we are at in the program. Let me get my material adjusted here, if you will. Okay, all right, so we're all set up, onward and upward. And I'm going to, I'm basically just reading through these. I sort of like, in case you didn't know, I sort of like treating these scholarly papers, the research results, as like a audiobook, a book on film. I kind of like having a very limited visual, and just so that way you can just kind of put it in the background and get a lot more out of it by kind of having it in the background, and you're doing other stuff, and you can kind of repeatedly listen to it over and over. At some point, maybe I'm going to do a podcast of these, but oh, good golly, it's just me doing all of this, and there's only so much I can do in a day. Okay. All right, so this is going to be part B, the second half of our discussion on the connection between VLF emissions and earthquake behavior. Okay, so onward and upward. And I'm just going to kind of go back what I've already read already, and I'm going to just kind of review. I'm going to just kind of review a little bit, and then we're going to move on. All right. So if you thought I've already gone over a little bit of this, yes, I have, and I'm going to move on from it. Okay. At the final third stage of the avalanche-like unstable model of fault formation, the relatively big size faults use to unite into one, the main fault. This process, according to our model, in case of emission spectrum monitoring, should correspond to gradual fall of frequencies in kilohertz, which, according to the Formula 1, refers to the increase of fault length in the focus. Increase in crack length in the focus refers to the increase in the magnitude of the incoming earthquake. And that's Ulomov, 1993. Okay, so they're giving us this equation. In the case of L'Aquila earthquake, due to the fact that on 4/04/2009, the main frequency kilohertz was already fixed in the electromagnetic emission spectrum. That's Papadopoulos reference 2010. The main fault in the earthquake focus should have been of kilometer order already. Okay. Of course, association of cracks into one fault, which at the final stage of earthquake preparation proceeds intensely, will use definite part of energy accumulated in the focus and therefore will result in its decrease. In such situation, a period settles before a long earthquake, which can last from several hours to even 2 days. When in the focus a fault is already formed, while earthquake has not occurred yet, since accumulated tectonic stress is not yet sufficient to overcome the limit of strength of geological environment. The system, which is waiting for further portion of tectonic stress, is in the so-called stupor. In the principle, the process of crack formation is not going on in it anymore, and respectively, electromagnetic emission would not take place. Although later, at the approach of critical value of tectonic stress, the balanced state in the system will be deranged and the earthquake will occur. This process is expressed correspondingly in the electromagnetic emission spectrum. Some hours before the earthquake, up to 2 days, in the spectrum, the emission intermittence is observed. Up to interruption of electromagnetic emission by the use of final value of the main frequency of the spectrum on the basis of the Formula 1. We can determine by a rather high accuracy the length of expected fault of the future earthquake, that is, a magnitude of the incoming earthquake. And the references are Kachakhidze 2011, 12, and 13. We can expect renew of electromagnetic emission immediately before the earthquake. In the period of electromagnetic emission monitoring, the moment of interruption of emission spectrum is urgent for determination of time of occurrence of incoming earthquake, since at the final stage of earthquake preparation, very short time is needed to fill in the critical reserve of tectonic stress needed for main fault realization. It should be noted that this fact was experimentally proved in the case of L'Aquila earthquake. In this case, this time lasted up to one and a half to 2 days. Often, in case of rather large earthquakes, we observe large force shock too. The main shock can follow large force shock rather swiftly. In this case, there is no reliable criterion which can distinguish large foreshock from incoming earthquake. Example of this is the L'Aquila earthquake, when it was considered that the incoming foreshock was the main shock. This issue can be resolved by rather high accuracy on the basis of analogous model to EM emission monitoring. Namely, in the case of magnitude equaling 5 earthquake, electromagnetic emission should equal to 95 kilohertz. In this case, fault length is the focus equals to approximately 3 kilohertz, and that's Kachakhidze reference 2011 and 12. If after this earthquake electromagnetic emission still continues to exist and the frequency data still tend to decrease, it means that the process of fault formation in the focus of the earthquake is not completed yet, and we have to wait for the main shock to occur. Generally, we should not expect stopping of electromagnetic emission after large earthquake, but the frequency values in the spectrum must grow, which will refer to the fact that we should not expect the larger than the occurred earthquake, but we have to wait for a series of aftershocks. This was well proved in the example of L'Aquila earthquake, and it's 2009. Since the process of developing of foreshocks and aftershocks generally are connected with the fault formation process, it is clear that at this time too, VLF, LF, electromagnetic emissions will take place, and those are references 2009, 10, and 13. Analogous model on the basis of electromagnetic emission enable us to evaluate magnitude of each separate foreshock and aftershock. Thus, good conformity of the above referred two models and capabilities of analogous model are evident on the example of real earthquake 2. Of course, in the whole world, rather interesting and significant works of geologists are dedicated to the study of issues of earthquake focus, foreshocks, and aftershocks. And the references are Amato 98, 2008, and Chiarabato 2009. But we will not deal with it in this paper. The present paper offers general, that is classical, quote-unquote classical, picture of earthquake preparation and occurrence. That's foreshock, main earthquake, aftershock. On the basis of analogous model and avalanche-like unstable model of fault formation. That is a mouthful. And finally, by the use of the formulas 1 and 2 for inland large magnitude equal to or greater than 5 earthquakes, we can make the scale of dependence of incoming earthquake magnitude even by the 0.1 accuracy on the final main frequency of electromagnetic emission fixed immediately before the earthquake. Thus, monitoring of electromagnetic emission before the earthquake on the basis of the offered models enables us to follow step by step the process of earthquake preparation and make prognostic conclusions by definite precision. Okay? As it is mentioned above, according to analogous model in Kachakhidze 2011, it is possible to detect the territory and the surface of the Earth in advance where an earthquake is expected, the epicenter area of an incoming earthquake will be approximately limited to the territory where the Earth's surface will have positive potential toward atmosphere. Electromagnetic emission in kilohertz should take place, namely on the territory adjoining the epicenter of a future large earthquake. Our opinions have been experimentally confirmed by the paper of K. Eflaxius, and that's reference 2009. It should be stated that during electromagnetic, VLF, LF, and ULF emissions fixed before earthquake, there is a problem of differential of ground-based electromagnetic emissions from magnetospheric emission, because of which it is impossible to prove reliably cause and effect relations among seismic and atmospheric, and that's ionospheric, phenomena. And that the references are 2010, 12, and 13. Of course, this problem is to be taken into consideration in the above-mentioned researches. Okay, all right. So that ends part B of this, and the next one is that we're going to go into the conclusions. All right. So, but for right now, that's over. I just wanted to break it up. Even though a half an hour might not have been that long, I just thought that this would be better as two shorter videos, and that way you can kind of play them. You don't have to be dedicated for half an hour to this. You can play one and then play another. And if you're on a YouTube restricted diet, that you could watch this and then still watch something of something else. So, all right. So, this is I'm going to go over this in another video, I think. But this is all the basic information here that we need to look at properly of how to see the data from Cumiana, which is a VLF station. This is one of that. It's up here, and this is the reading from yesterday. I think the next video, I've been using the same
basic backdrop for 4 videos now, and this is all in actually yesterday. So today's another day. Takes a little while to make these, so today's another day, and I think I'm gonna have to put up the new data for the next part of this. So thank you all for being here. I appreciate all the comments, the love, the support. Thank you all very much. Have a great rest of your day. I shall see you in the next part of this, and I very much appreciate everyone for being here. Thank you for making this more interesting. Have a great rest of your day. Namaste.